Hi, in this video I'm going to be adding a MIDI sound module to my vintage XI8088 PC. So I've got a couple of these that I bought on eBay. Unfortunately, I never got to own one of these back in the 80s or 90s when it would have been popular to do MIDI for the old Sierra games. On the positive side, that means I can try it out now. These modules would have been quite expensive back in the day. I think like $600 plus. You'd have had to have been pretty serious into your Sierra games to buy one of these just to play games back then. So the first one here is a Roland MT-32. This was the super popular one at the time. It's got a display, it's got some buttons, volume control. On the back, there's some ports, so there's MIDI ports, in, out, and through. So in and through are kind of electrically routed together so that you can daisy chain multiple MIDI devices together. You connect the in to the out from your computer, then you connect the cable from the through to the in on the next one, and then keep on going. Don't know what you'd use the out for on an MT-32. Don't know if anyone ever did. There's a couple of mono stereo jacks back here for the output. A right and a left, so you want to get yourself some adapters, plug them in, and then we've got RCA, and we can plug normal RCA plug onto there. Power switch is on the back. Now the power is wired backwards from what you'd normally expect. It's center negative. Kind of annoying because most adapters are center positive, so just be aware of that. There is an official Roland adapter. Got one sitting back here. It's kind of a big brick thing. Came from eBay when I bought this. Big, heavy, clunky linear transformer. It's 9 volt. So that's the MT-32. This came out before the general MIDI standard, so the instrument banks are different than general MIDI instruments. That may cause you some grief depending on what game you're trying to play. If you hook up a general MIDI synthesizer to a game that's written for the MT-32, or you hook up an MT-32 to a game that's written to general MIDI, you get the wrong instruments. So be aware of that. There's also an early and a late version of this, so this is the early version. You can tell because it does not have a headphone jack, it just has the right and left. So the other module that I'm going to try out today is the SC-55. This is a little bit newer. It supports the GS standard. There's a little GS logo down there. Supports, I believe, more simultaneous channels and stuff. Has a nice LCD display. Does have an Roland MT-32 emulation mode. To put it into the emulation mode, you just hold down power and this to turn it on, and then it'll boot up and say, switch to MT-32, and you hit the all button to say yes. That's what you'd want to do to play an MT-32 game on it. Back panel's a little bit more modern in that we have actual RCA jacks. You've still got the 3 MIDI connectors, the in, the out, and the through. You've still got the center negative plug. But either one of these can be found on eBay these days for like around $100. You might get a deal as low as like $60. You might spend more, like $120. But average somewhere around $100. Now, to use your sound module, you can use it with a modern PC by use of a USB to MIDI adapter. It comes with 2 plugs marked in and out. You hook the out on this to the in on your module. You hook the USB connector up to your modern PC, and then you can load up DOSBox and play your retro games using the hardware MIDI synthesizer module. Unfortunately, this isn't going to work for my XI8088 because it has no USB ports. And even if it did, it would probably be far too slow to sequence the music out the USB port. So how are we going to get this MT-32 module to work with this old home-built 8088 PC. I didn't know much about this when I started. You know, I knew that sound cards like the Sound Blaster had a game port. The game port was wired for Midi. But then I read up that's not going to do me any good because those modern sound cards only implement something called UART mode, whereas old DOS games are written to something called intelligent mode. So what you need is something called an MPU 401. Now here's a picture of an MPU 401. Unfortunately, these are very, very difficult to find these days. I don't know if they were all thrown away over the years or parts were lost. But while the modules like the MT-32 seem plentiful, the MPU 401s are like almost unheard of and go for $400 or more when you do encounter one. So that's kind of a bummer. There are a couple of alternatives. There's something called soft MPU, which will emulate the intelligent mode of the MPU 401. But it requires you either run QEMM or EMM386, which is going to require a more modern processor than the 8088 in my XI8088 Retro PC. So soft MPU is not an option. There's also a guy producing clones of the Music Quest MPU 401 adapter, so he's kind of making a clone of a clone, which is great because then you could have something that's actually period accurate, but cloned into modern hardware and therefore available. Unfortunately, there were none of those available for purchase at the time I wanted to do this, so I couldn't go that route either, but that would have been a nice alternative. And then finally, there's something I came across called HardMPU. This is a project I found at Vogons. Vogons is a great forum for looking into retro gaming and retro computers and such. So the HardMPU, what someone did is they took an AtMega microcontroller, they put it on an ISA card, put the necessary glue logic so that the AtMega could talk to the host PC, and then they took the soft MPU code and ported it to the AtMega. So we end up with an actual hardware implementation using more modern processor, the AtMega. You don't have to run QEMM or EMM386. It looks just like an MPU 401 would to a game, so just run your games as is, and it all just works, and I'm going to show that at the end of this video. So let's talk briefly about Midi, how it works, what a Midi file looks like, and how you'd play it. So Midi has a bunch of tracks. There can be up to 16 tracks. I kind of drew 3 tracks on my sheet. And each track will have a bunch of events. So events are these little blobs that I've written here. And an event typically consists of a delta time and a command, like on or off, and then a note number, and then there's also a velocity, which is like how hard you hit the note. I didn't draw in the velocities on this. I only fit so much on this sheet of paper. So time always marches forward. Each event has an individual delta. So let's take a look at track 1. So track 1 might say delta 0, turn on note 7. That says, you know, immediately turn note 7 on. And then it might have something else that says down here, you know, delta 20, turn note 7 back off. So what we would do is we would have note 7 would be on for 20 ticks of the Midi clock, from 0 to 20. Maybe track 2 over here has delta 10, says note 6 on. Then down here at delta 40 it says note 6 off. So there we've got 30 ticks starting at delta 10 that note 6 would be on. Now you can play multiple notes at the same time. So here, over here on track 3, I've got delta 0, we turn note 26 on. Delta 15, we turn note 31 on. Delta 40, we turn 26 back off. And delta 60, we turned 31 back off. The important thing is that you need something called a sequencer that keeps track of all of these, keeps track of the master clock, and fires off these note messages to your module at the right time. Now, a modern PC, of course, this is trivial to run this. I mean, we just have a clock ticking and we just output these things at the appropriate time. Our old vintage 8088, this is kind of a lot of work to do all this real-time sequencing. You know, if you've got 8 tracks, each track is playing different notes. You've also got a percussion track that's playing the drums. You've got all of these timings to keep track of. You've got the serial port to operate when you're talking to the Midi device. That's a lot to burden down a vintage CPU with, so what they did is they came up with intelligent mode. And intelligent mode basically means you've got a separate coprocessor on the MPU 401 device that implements this sequencing. So rather than having the host computer keep track of all these, the host only sends these events to the MPU 401. You know, the MPU 401 will say, what do you want me to do with track 1? Host will say, at delta 0 you turn 7 on. Then the MPU 401 will say, okay, I did that, what's next? And it says, okay, the next thing you're going to do is at delta 20 you'll turn 7 off. But the MPU 401 is handling all this timing of keeping track when to fire all of these. Just keeping track of all the tracks, the running delta counts. So that offloads that task from the CPU. Unfortunately, you know, that's a bit of work to implement this. So as computers became more modern, your more modern cards, your sound blasters and such, they didn't implement intelligent mode anymore. They only implemented UART mode, which makes the host do all this work. That means we can't really use that for a vintage game like, say, Space Quest 3 that expected intelligent mode, or King's Quest 4 also expected intelligent mode. So we need to come up with an intelligent mode card to run in our vintage PC. And that's what we're going to do next. So let's take a quick look at what the HardMPU board is and how it works. So this schematic, this is not my schematic. This schematic came from the HardMPU project by a user called ABOTJ, A-B-O-T-J. He put it up in his GitHub with the note that it can be used for non-commercial purposes. So I'm not going to really go into like huge detail on this thing since, well, you can just find him on a forum and ask him about it, or you can browse the schematic on GitHub. Just a few basics of what it does. You know, it's got the PC bus, it's got the AtMega CPU. There's logic over here that goes to the Midi port. There's always an optocoupler on your Midi in. Your Midi out is just a line from the microprocessor through a 220 ohm resistor. There's also some power that goes out to the DB9. Standard MIDI interfacing stuff that you can find lots of circuits like this on the internet. Over here's where the really interesting stuff is. So you need to interface this microcontroller to the PC ISA bus. It does it through a couple latches. One latch is a read latch, the other is a write latch. So when the microcontroller wants to send data to the host, it puts it in one of the latches, then the host can come along and read it out of the latch. The other way, you know, when the host wants to write something to the microcontroller, it writes it to a latch, and then the microcontroller can read from that latch. There's address decoding, you know, typical 74 138s that set the addresses of these latches on the ISA bus. There's a buffer down here that supports a status register, so you can read the state of the latches. You'll know when the latch is clear to read or write. Then there's all of this interesting flip-flop stuff that manages states of the latches, so that, you know, it coordinates the setting the latch is enabled. So it coordinates setting the signal. If there's data in the latch, the PC comes, reads the data, it clears the flip-flop, and then we coordinate and we know that the handshake is complete. So anyway, I encourage you to go find this on GitHub. You know, look through the schematic, figure out how it works, look through the source code, figure out how it works. It's a really interesting project, and it's really cool that that this user came up with this thing. Anyway, I'm going to build one, and I'm going to install it in my vintage XI8088 and try it out. So here is the PC board that I built. So I'd like to stress this is not the official board that you would buy online from the guy who invented the HardMPU. This is one that I created based on his schematic. I input the schematic into Eagle, auto-routed it, produced a board. The reason I didn't buy one of the official boards is they just weren't available, and I was impatient and wanted to build one right now. So this is what I came up with. The layout is very similar to the official one, although the routing is probably completely different because I just use Eagle's crappy auto router to make this one. So over here, this is the AtMega CPU. There's the address decoders. Some of the latching stuff is over here. the optocoupler. We've got the 2 flip-flops. I don't really remember what that thing was there. Some important glue logic. The DB9 resistors scattered throughout. Jumpers for IRQ and port. Headers for JTAG programming, expansion, etc. Fuse holder. So I added up here, I added a spot to hook up an activity LED, wired it to one of the unused pins on the AtMega. I have no idea if that's going to work, but I'll take some modifying of the firmware to try to do it just like LEDs on things. So anyway, just a simple translation of the schematic that I found online to a board. Let's put it in the computer and try it out. Here is the Midi card installed in the XI8088. It's this one right here. Alongside of its floppy controller, the other side's VGA. Here is a game card and parallel I/O that I built another project, and the CPU board's over here. Compact flash storage is over there. My bus terminator board is there. Okay, so everything's hooked up over here. I've got my XI8088 home-built computer. I've got the HardMPU card that I built in there. The MT-32. There's cable going from the MT-32 to the HardMPU card. I've got monitor, keyboard, speakers. So let's turn on the MT-32. Let's turn on the XI8088. Booting up. See, my Nixie clock TSR program's already started running. So I have one game installed on here which uses the MT-32, and that's King's Quest 4. It's a little bit slow for an 8088, but let's give it a shot. Sierra. Let's turn the volume up where we can hear it. So you can see the game is able to update some stuff on the MT-32's display. It says King's Quest 4. Expecting some. There we go. And sound came out of the speakers. Takes a while to load the game on old PC like this. Okay, we get the idea. Skip. So I also wrote a MIDI player, an intelligent mode MIDI player. I couldn't find any intelligent mode ones. I could find lots of UART MIDI players, but I wanted to do intelligent mode since I just built the card and wanted to try it out. So I wrote my own player to work with it. Called it MIDI Play. Argument-P buster.mid. I've started by downloading some very simple MIDI files. So this first one was Ghostbusters theme. You have to get, if you're using an MT-32, you need to get MIDI files that are designed for the MT-32 because it has a different instrument table than general MIDI devices. So concentrate. I found an FTP site that had a bunch of old MIDI files. So here's Ghostbusters theme. So you can see the MT-32, it's showing what channels are being played. And we can exit. Got some other MIDI files here. Phantom32.mid. It's like a Phantom of the Opera thing. Then I've also downloaded, I found a site that had music of the Monkey Island game, so I've downloaded some of that. So let's MIDI play-p monkey / mi1.mid. Takes a little while for this one to get going. Crank up the volume. One of the advantages of the intelligent mode is it can run in the background. It was designed to do that with games because you're playing the game in the foreground. You can't have the host computer tied up playing music the whole time. So I did add sort of simulated foreground work, which is this -R option, which will let us compute prime numbers. So let's do monkey. I sort of use the world's most inefficient prime number algorithm on purpose, so it runs and does lots of work, but there it is churning out prime numbers in the foreground while the music player is playing music in the background. Kind of my idea is I could take this and I could make another terminate and stay resident program so you could actually play the music in the background while doing other stuff on the computer. Yeah, so that's working. Exit it. I also have like some diagnostic stuff that I built into this. -p-o. Monkey. Let's do that. So there, we're actually seeing the data that's being sent to the MPU 401. It's probably going very, very fast for you. Okay, so here's a close-up of the diagnostic screen. I was using this when I was diagnosing problems with the player while I was working on it. It shows incoming requests from the MPU 401 and the responses to them. So for example, a track data request came in on track 1. We sent out an F8. F8 is the signal that we don't have a note to play at this time. So what we still had is a delta of 1970 ticks. So we sent that F8 out, which says contact me again later and I'll have something for you later. Then a track data request came in on track 4, delta of 49 ticks. The message was a 4F, which is a MIDI running status that says I want to play the same note, or I want to play a note on the same channel that I've already played it. So then we sent the response out to the MPU 401. So we sent 31, that's the delta. That's in hex. 31 hex is 49 decimal. 94, that's a MIDI command, something like start note, stop note. I don't know which one it is offhand. The least significant bytes, or the least significant bits, are the channel. So the 4 is for channel 4, which is the one we got a request on. The 4F was our note. So it's, you know, like key on the piano. And then 30, I believe that's like the hardness at which the musician pushed down. So that was a voice message. We sent that out. Then so later came another track data request on track 4 that would have been 31 ticks after the previous one we answered. So here now we've got a delta of 52 that we want to send this out at. A 4E is the note that we want to play. That's another MIDI running status. So we're sending a delta 34. That's hex version of a 52 decimal. 94 is the MIDI command. 4E is the note. And then 30 is how hard the key on the instrument was pressed. So, and then we sent the voice. So yeah, that was sort of shows you what all is going on with this. And if you run the player, MIDI play dash P dash. Did I spell that wrong? Yeah. You can see that it's streaming this stuff constantly out the MIDI port. Okay, so let's try out the SC-55. I'm going to try this out on my modern Windows PC, just for some variety in today's video, using the USB to MIDI cable that I showed earlier. I could have used this module on the vintage PC, or I could have used the MT-32 on the Windows PC. Either module works for either purpose. In this case, we're going to use DOSBox, which is an emulator that will let us run our old games on the Windows PC. First, we have to set up DOSBox so it knows to put the MIDI out to the USB cable rather than to use its internal Windows wavetable synthesizer. So we're going to type this command mixer/list MIDI. That's mixer/list MIDI, and it lists the devices. So the first device is the Microsoft synthesizer. It's device 0, we don't want that one. Device 1 is USB 2.0 MIDI. That's something to do with our MIDI adapter, but device 2 is the one we really want, which is MIDI out 2 on our USB adapter. So that's the one we're going to choose. Next, we're going to go into the DOSBox settings. Let me bring those up. DOSBox options. And we have to just find a section here called MIDI. And then we have to change this MIDI config line to say MIDI config equals 2. Then we'll save this file, restart DOSBox, and we're good to go. So first, let's turn on our SC-55. We want to do it in MT-32 emulation mode. So I'm going to hold down the instrument button that points to the left, and turn on the power button, and then it says here at the top, it says init MT-32. Sure, we say push the all button. That has initialized it to MT-32 emulation mode. Okay, so first I'm just going to play that very same Monkey Island MIDI file that I showed you on the vintage PC with the MT-32. Let's play it from the Windows PC using the SC-55. That was Monkey Island file number 1. Kind of playing through my crappy monitor speaker, so it may not sound quite as good, but you can see the Roland module. It has this nice little graph that shows what channel the notes are being played on. It'll look more interesting once it really gets going here. There. Okay, so let's try playing Space Quest. I'll pan over here to the monitor so you can at least have some view of what's going on. Type Sierra. Should start Space Quest. There we go. Now it's kicked into high gear. Let's look down here at the SC-55 again. I've linked several resources right here at the end. The first is the GitHub repo for my Midi player. This is the intelligent mode Midi player I wrote that works with MPU 401 style Midi interfaces. Next is the Nerdly Pleasures MPU 401 page. That'll tell you what cards work in intelligent mode, you know, which ones you can use, which ones you should avoid. Next we have the Vogon's HardMPU thread. That's where you can find the guy who developed the HardMPU, and he's planning on offering kits and boards and stuff. Next up is his GitHub repo. That's where I found the schematic and also the source code and the binaries for programming the AtMega microcontroller in the HardMPU. Thank you for watching my video. Please visit my website at www.smbaker.com for more electronics projects and Sandrail stuff. Bye.